Hi there, welcome to my channel. In this video, I'm going to discuss about sorting the elements in the linked list. Let's look at the problem description. We are given the head of a linked list and we have to return the list after sorting it in ascending order. Let's take a look at the example 1. The given linked list is 4, 2, 1, 3. After sorting, the list will be 1, 2, 3, 4. And in the example 2, the linked list has 5 elements minus 1, 5, 3, 4, 0. The sorted list will have minus 1, 0, 3, 4, 5. If the linked list is empty, then the output also empty. The number of nodes in the list is in the range from 0 to 50,000, and each node value will be in the range from minus 10 to the power 5 to 10 to the power 5. We are expected to sort this linked list in order of n log n time and order of 1 memory. Let's look at the approach to solve this problem. We are given a linked list with 4 elements 4, 1, 3, 2. The expected sorted list will have the elements in the order 1, 2, 3, 4. Basically, we can solve this problem using a divide and conquer approach. So we keep dividing the given input list into 2 sublists until we reach the sublist with only one element. Once we reach there, then we merge list from the bottom up. So for example, this linked list is divided into 2 sublists. One with have 4 and 1, and the second list have 3 and 2. Okay, and this list in turn divided into 2 sublists. The next level sublist will have single element in the left list and the single element in the right list. So this is in already a sorted form. So from here we keep merging backward. So these two lists will be merged such a way that the final list is in an ascending order. 1 will become the head of the linked list and 4 will be added as the tail of this merged list. Okay, we keep doing that as we go up, and finally we sorted list. That's what I have written here. So basically we use the divide and conquer approach and build the sorted list from bottom up. If the list is empty or a single node, we return the head of the linked list. Otherwise, we split the list into 2 sublists and then sort the left sublist and the right sublist recursively, and then merge the sorted list returned by these 2 calls. Okay, and finally return the head of the merged list from this function. Let's look at the flowchart. Input for this procedure is the head of the linked list. First we initialize the left list head and the right list head, sorted left head and sorted right head pointers to null. Okay, then we check whether the given input list is empty or it has single node. If that is true, we simply return the current head as the new head of the merged list and then return. Otherwise, we find the middle element in the given linked list and assign the head as the left list head, and then next node of the middle node is set as the right linked list head. And then we call the sort list function recursively to sort the left sublist pointed by the left list head and assign the return value to sorted left head. Then we call sort list recursively with right list head and assign the return value to sorted right head. Once the left and right sublists are sorted, then those 2 sorted sublists will be merged. We call the merge list function to merge the sorted left head and the sorted right head list. Then we assign the return value to new head and return from this function. Let's move on to coding. First I initialize the left list head and the right list head pointers to null, and then sorted left head and sorted right head pointers to null. Here I check whether the input linked list is empty or it has only one node. In either case, I return the head of the linked list as the output. Next, I call the find middle node function to locate the middle node in the linked list. Next, I assign the head pointer to the left list head, middle node's next pointer to the right list head. Next, I divide the linked list by setting the next pointer of the middle node to null. Then I make a recursive call to process the left sublist and assign the return value to sorted left head, and make another recursive call to process the right sublist and assign the return value to sorted right head. Next I call the merge list function to merge the sorted left head and sorted right head linked list and assign the return value to new head pointer. Then I finally return the new head as the output. Next I am going to write the find middle element function. This takes the head of the linked list and returns the pointer to a node. First I initialize the slow and fast pointer. Slow points to head and fast pointer points to the second node in the linked list. Then I write the for loop. This loop runs until both slow and fast pointers are equal to null. Each iteration I check whether the fast pointer's next node is not equal to null. If that is true, then I update the fast pointer with fast pointer's next node's next pointer. Basically I advance double the time compared to the slower pointer. If fast dot next is null, then I break out of the loop. Otherwise I update the slow pointer. Then finally I return the slow pointer. This will point to the middle element in the linked list. Next I write the merge list function. This will merge two linked lists and produce the sorted list. So the logic used here is similar to a merge sort. This function takes the left linked list head pointer and the right linked list head pointer and returns the pointer to the merged list. First I initialize the new head and new tail pointers to null, and then I write the for loop which runs as long as the left and right are not equal to null. If both are not equal to null, then I compare the value of the node pointed by the left and the value of the node pointed by the right pointer. If the left is less than right, then I add the left node to the new linked list and then I advance the left pointer. Else I add the right node to the linked list and advance the right pointer. If either one of them is null, then we break out of the loop and then we in this loop try to scoop the leftover elements in the left sublist. So this loop runs until the left becomes null and we keep adding the left sublists remaining nodes into the output linked list and advance the left pointer. Similarly, we scoop the right sublists elements if there are any in this loop and advance the right pointer, and I return the new head as the output. Next I am going to write the add node function. If the tail is null, then I set the current node as the head of the linked list as well as the tail. Otherwise I make the current tail node to point to the new node and then I make the new node as the tail node. Next I am going to run the test cases. Let me rerun the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. We are given a linked list with 3 nodes and they are 3, 1, 2 and the expected output have the numbers in the order 1, 2, 3. So first the left list head, right list head, sorted left head and the sorted right head all are initialized with null and the head pointer pointing to node 3. Okay. First we check whether the head is null or the head next is null. So in this case both the conditions are false. So we go ahead and try to find the middle node of this linked list. Once we locate the middle node, we set the current head as the left sublist head. So the left list head pointing to 3 and the right list head is pointing to the next node of the middle node. So we found the 1 is the middle node. The next node of the 1 is 2. So the 2 will be the head of the right linked list. Okay, and then we terminate this linked list by setting the next pointer of this node to null. Okay, then we call sort list function recursively to process left list head and the right list head. Okay, so the frame 1 is created. When we enter, first call is to process the left sublist. So that's why the head is still 3 and the all other pointers are null. Okay, so here also we check whether the linked list is empty or it has only one node. So in this case it has 2 nodes, so this condition is false. So we go ahead and find the middle element in the linked list. We find 3 is the middle element. We set the current head as the left sublist head. So 3 will become the left list head and the right list head will be pointing to node 1, and then we delink this node from the linked list. Then we call again sort list function recursively to process this single node. And when we enter here, first we check whether the list is empty or it has only one node. So in this case it has only one node, so we simply return the head. So the sorted left head will be containing only one node, 3. And similarly when we call the sort list function to process the right list head, we have only one node, node 1. So we simply return the head as the new head. Okay, so the right list head will point to this linked list, and then we come back to frame 1 where the merge list function is called. So when we call this, when we reach here, the sorted left head pointing to 3, sorted right head pointing to 1. Okay, and in the merge list function we merge those two lists such a way that the final list is in a sorted order. So here we check whether the left and the right is not equal to null. In this case both are not null. So we go ahead and compare the value of left node and the right node. Okay, so the left is 3 and the right is 1. And this condition is false. The else part will be executed. So we add the right node to the head of the new linked list, and then we update the right node. The linked list will have 1 and the right pointer will become null. So we will break out of this loop because of this condition. And when we come out, we have the left linked list has some elements. So we scoop all the elements in the left linked list here. Okay, so we keep adding the elements in the left linked list. In this case only one node is there, so that will be added after node 1. And then we update the left pointer, and then we break out of this loop. This right pointer is already null, so we will not execute this. And finally we return the new head, which points to the head of this merged list. This list is in a sorted order. Next we make a recursive call to process the right sublist in frame 1. So that sublist has only one node. So when we make a recursive call to sort list, it will return from here. So the sorted list has only one node, which is 2. Once this is completed, then again we merge the two sorted sublists. So when we come here, the sorted left list is 1 pointing to this sublist, the merged sublist, and the sorted right head points to this linked list. Then when we merge these two, we get this sorted list, and finally we return the head of this sorted list. So the final linked list have an element in the order 1, 2, 3. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Time complexity for this procedure is order of n log n. Okay. Let's take a look at this case. Given linked list has 4 nodes, 4, 2, 1, 3. And if you look at it, when we make a recursive call, so here we keep splitting the linked list into half until we reach the sublist has only one node. So when we process this linked list, 2 levels of recursive call. If you look at it, at each layer we process n number of nodes. Okay, so when we call the sort list function, first we divide the input linked list which has 4 nodes. Okay, and at this layer this call process 2 nodes, this call process 2 nodes. At this layer this call process 1 node, this is processing 1 node, this is processing 1 node, this is processing 1 node. If you calculate the total number of nodes processed in each layer, it is equal to the number of elements in the linked list. So here if you see 4 elements, here 2 plus 2 4, here 1 plus 1 plus 1 plus 1 4. Okay, but in this layer we are not dividing the linked list anymore, and also we are not merging the linked list. Okay, we return the head. We are not dividing or merging the linked list in this layer. In these 2 layers we divide the linked list and also we merge the linked list on the way back. The total number of link manipulation done by these, the find middle node and the merge list function, is number of layers minus 1 times number of nodes. So the number of layers minus 1 is equal to the height of the tree, which is log n. So in this case we have 4 nodes, so the total number of processing is 2 times 4 8. If we have n nodes, then the total number of nodes processed is n times log n. So that's why the time complexity is order of n log n. Space complexity is order of 1 because we are not allocating any additional space to store the intermediate list. We manipulate the links of existing linked list, so that's why the space complexity is order of 1. Thanks for watching this video. Have a great day.